Okay, let's do a couple more examples from our simplifying rational expressions worksheet. Let's start with mm, let's start with number 14. And so anytime you're working one of these, if you have a quadratic in the numerator, the denominator, or both, you're going to want to look at those individually. So I'm going to look first at I'm going to look at the numerator and try to factor it. Obviously, if there was a common factor in the numerator and denominator, you could take that out. But if not, you're going to start factoring the numerator and then factor the denominator and then look for those factors. So I'm going to start with 5n squared minus 18n minus 35 and factor that. So how do I factor that? Well, the leading coefficient is at 1, so I guess the most consistent option is to multiply that by the final number, and you'll get negative 175. And then you need factors of negative 175 that add up to the middle term, negative 18. Okay? If you need to, you can go to your calculator, and in the y equals, you could type in negative 175 divided by x, and go look at the table and see if you find, or go until you find two factors in that the x and y list that multiply or that add up to negative 18. If you do that, you'll find negative 25 and 7, and then we can rewrite that middle term as negative 25n plus 7n minus 35. And so you see nothing has changed in the numerator except we have split that middle term into two terms. And that allows us to do something very helpful. We can factor by grouping. So first group and second group. Well, out of that first group, we can take out a 5, and we can also take out or factor an n. And that leaves us with 5n times n minus 5. Okay. And then, if you're factoring by grouping, you need the same thing again in the other group, n minus 5. So what do I multiply by n to get to my 7n? That would be a positive 7. And then you want to check yourself. You can say negative or positive 7 times negative 5 is negative 35. So my factors are correct. Okay, so the final factorization of the numerator, 5n plus 7 times n minus 5. Didn't leave ourselves a whole lot of room here. So I'm going to erase this, and over here I'm going to factor the denominator. So in the denominator we have 3n squared minus 6n minus 45. Well, I know 3 and 6 are divisible by 3. What about 45? Yes, it is. So that means I can factor out a 3. Because 3 times n squared is 3n squared. 3 times a negative 2n gets me that negative 6n. And 3 times negative 15 will get me the negative 45. So this is equivalent to the denominator. All right, now I just need to factor the part that's in parentheses. So since the leading coefficient's 1, I need factors of negative 15 that add up to negative 2. That would be negative 5 and positive 3. So negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So the denominator will factor the n minus 5 and n plus 3. Okay. So now I'll go back over here. This was my numerator, and I will put the denominator here, n minus 5, n plus 3. Okay. Well, in the numerator I have an n minus 5 as one of my factors, and then in the denominator I also have n minus 5. If you divide n minus 5 by n minus 5, you get 1. So those divide out, and I'm left with a final answer of 5n plus 7 over 3 times n plus 3. All right, let's go ahead and do So that's number 14. Let's go ahead and do number 15. And I'll see if I can take up less space. All right, number 15. There's a greatest common factor in the numerator of 10. So we'll factor out a 10. And that leaves us with 5 minus 7k. In the denominator, we also have a greatest common factor of 10. So I'll factor that out, and it'll leave us with 49k squared minus 25. So I have a 10 divided by 10. That's just 1, right? So those divide out. Well, the numerator can't be factored anymore, but the denominator, I have a quadratic function. And if you know your perfect squares, you can see that that would be the difference of two squares. Okay, so the difference of two squares factors into the square root of the first term. So what's the square root of 49? 7. It's the square root of k squared, k. Now you can double check yourself. 7k times 7k, that equals 49k squared, right? Okay. And then the second term, 25, the square root of 25 is 5 plus or minus 5. So now we have 5 minus 7k over 7k plus 5, 7k minus 5. All right? None of these are exactly the same, but are any of them exactly the opposite? Well, here I have a positive 5, and here I have a negative 5. Here I have a negative 7k, and over here I have a positive 7k. So those are exact opposites, like 4 and negative 4. 4 divided by negative 4 is negative 1. So these divide out to equal negative 1. So my final answer is negative 1 divided by 7k plus 5. And that 7k plus 5 stays in the denominator where it was originally. With that, I'll go ahead and stop this video and do a couple more here in a little bit.